I am Swimpy Pahuja, Assistant Professor CSC Department, Ajay Kumar Garg Engineering College, Ghaziabad. Today I will be delivering a lecture on the subject data structure. The course code is KCS 301 and I will be starting with third unit. The topic will be the searching. So let's start. These are the contents that I will be covering. First, I will be giving an introduction, what is searching. Then I will be covering various searching algorithms like linear search, binary search as well as index sequential search. So, introduction to searching. Searching here is an operation which is basically used to find the actual location of a particular element in the given list. And if a location of that element is found, or we can say if that element is present in the list, then we say that search is successful, otherwise we say that search is unsuccessful. So, it depends whether the element is present in the list or the element is not present. Based on that we can say that the search is successful or unsuccessful. So, these are the various searching methods, like we have linear search method, we have binary search method as well as we have index sequential search method. So, these three searching methods we will be covering. These three searching methods we will be covering. First one is linear search. So, linear search is a very simple search algorithm which is used to find the location of an element in an array using this particular method. So, basically it is used to search in an unsorted list in which the items are not sorted. So, before explaining this algorithm, I want to explain the example, because using the example we will come back to the algorithm. So, now how linear search works. Here is an example. I am given with this 5 arrays, and in these 5 arrays I want to search for this value 1. Fine. So, in order to search for this particular value using linear search method, what we need to do is we need to scan this array starting from left to the right. So, now how we will proceed. First, we will check for the very first position. The very first position is having this index value that is equal to 1. That index value is checked for this very first position. So, in this very first position we have the value 2. This 2 is not equal to the value 1 for which we were searching for. So, because it is not equal, so we will move to the next position. So, here we are moving to the next position. So, we will check for the next position value. So, this next position value is having the value 4. Now, this 4 is also not equal to that 1 for which we were searching earlier. So, again we will move to the next position. So, when we will move to this next position, now this is having the value 0. This 0 is again not equal to the value 1. Fine. So, again we will move to the next position. So, this will be our next position to which we will move, and here when we will move to this next position, we will be able to find out our value 1 for which we were searching. So, now what the algorithm will do, algorithm will return the address of this particular position. Now, because this is an array, so in order to do it in terms of program, the index value of array, as we know, it starts from 0. So, if I write the index values over here, so index values are 0, 1, 2, 3 and then 4. Fine. So, these are the index values. So, I found this this value 1 for which I was searching for using linear search method at the index position 3. So, if I name this array by A, so I can say that I found this value at position number 3. Which value I found? That is the value 1. So, here after getting that value, the algorithm will stop and we can just return and we can exit with the algorithm. But if I consider the case that okay, this value is not 1, this is something else. So, if I take, let us say this value is 5, fine. So, now when the algorithm will proceed, here 5 will be compared with the value 1. So, they are not equal. So if they are not equal, then again it will move to the next place. Now here again the next positional value, that is 9, it will be compared with the value 1, again they are not equal. So now there the array has completed, there is nothing to move forward. So in this case what will happen, because we have not found this value 1 anywhere in this array, if I change this value 1 to 5, so in that case my search is unsuccessful, and if the search is unsuccessful, the algorithm will return that we have not found the element for which we were searching for. And if the search is successful, in that case when this value was 1, it will return this position, that is position value 3. Fine. So let us come back to the algorithm now. Using this example, we will be able to explain the algorithm very easily. So now this is the algorithm. So here what we need to do in order to write in terms of algorithm, so we were having an array, this was the thing, we were having an array, this array was named as array A. Fine. So now in the algorithm we will start with a loop in order to check for the positional values of A. So because this is an array, so its index values will start from 0 in a program, as I said. So if I consider that okay, this is an array of size 6, fine. So here the index value is starting from 0, the very first value, and when we will start, so I am taking one variable j, and this j is having these index value. This j is keeping track of these index positions of this array A. Fine. So now what I have to do is I have to check every positional value over here in this array one by one. Now in order to check this positional value first, then this positional value, then this positional value, then this, and so on. So in order to check this, what I need is I need a loop. So what I will do, I will start with this loop. This loop is going from j equal to 1 to n. Now you will say that here it is 1, here it is 0. Why? Because this is an algorithm. When we talk about algorithm, we start the indexing from one value. When we talk about program, we start the indexing from 0 value. Fine. So here writing 0 or writing 1. So if I am writing 1, this is one and the same thing in terms of program writing 0 for considering the very first value. Fine. So now what we will do, we will just start this loop. Loop is going from 1 to n, where n is total size of this array or this list, whichever you are taking. Then after that we will check whether item is equal to aj. Item is what? For which I am searching. So item is for which value I am searching for. Like in my example, the item value, in this example, the item you are searching for was 1. Fine. So this is actually this variable, instead of k in the algorithm, it is taken as item. Fine. So now if I come back, so item value was 1 for which I was searching for. So I will check, I will compare, what I will want to do is I want to compare these two values. So I will compare this value of item with the value which is present here at this position. Fine. So for that I have started the loop. So here I will take the if statement, and this if statement will compare these two values whether they are equal. If they are equal, in that case it will return that item is found at position, and which position? Positional values are kept in variable j. So item is found at position j. Fine. Otherwise, if it is not equal, in that case what it wants to do? If it is not equal, it will move forward. Fine. And it will keep on running in this loop till n number of elements. Now if for the case of unsuccessful search, if this total number of elements exceed, if this j, the value of j, because it will keep on incrementing using this for loop. Fine. So if this value of j will reach to this last position and we have not found anything over here while comparing, so that means our search is unsuccessful. Our item does not exist in the list. So same thing, if j is greater than n, so in that case the item will not exist and we can exit, because in algorithm we write the last step is exit, so we always write exit. So this is linear search algorithm. Next is binary search. So binary search, now linear search is having one problem. If you can see here, what I was doing is I was just comparing every element one by one. Now if here my array size is very small, if I say my list is of 100 elements or maybe 10,000 elements or maybe more than that, so in that case will this search algorithm will prove good? Will it serve better? No, because for a very large size of values, for very large size of items, we will not be able to search for this value in a less amount of time. So my time complexity here, that will increase. So the time complexity here will be increased. So this time complexity, in order to decrease this time to access, to find out the location of this element for which we are searching for, the next algorithm came into existence, which is binary search. So that's why we say that binary search is a fast search algorithm, and the runtime complexity of binary search is big of log n, while that of linear search is big of n. So this linear search was having the maximum searching time because n is greater as compared to log n. So that means this is taking less time as compared to this linear search algorithm. So binary search works on the strategy of divide and conquer, and for binary search the array needs to be arranged in a particular order. So this is a you can say preliminary requirement for binary search, that whatever elements are present, these elements needs to be present in a particular order. So now what it will do, it will look for the middle item, it will look for the very middle element present in your whole list or maybe in the whole array, fine, and then the comparison will be done using this middle value only. So what we will do, we will check this is my array, fine. So in this array, what I will do, I will check for, let's say this is the middlemost position of this array. So I will check in this position that whether like if I say my item value is 25, fine, and let's say these are the values here, 30, 12, then 2, okay, let's take it 32, then 42, then 52, then 70, fine. So this is an array. So now I am searching for 25 value in this array. So what I will do, I will compare with the middle element. If in the middle element this value is not matching, so in that case we will check whether this 25 is smaller than this element, than this value 42. So if I see 25 is smaller than 42, so what I will do, I will check in the left side of the list. I will not see the right side of the list in this case. So my comparisons are already reduced. I am not doing comparison with these two elements now. I have just removed them from the list, fine. So now I am doing comparison with these elements which is on left side, because 25 for which I am searching for is less than 42 and the list given is in sorted order, fine. So now again here this is not matching. So again what I will do, I will check for this much list only in the left half, and I will again find the mid in this left half, middle value, and with that middle value I will compare this 25 again, fine. So same thing is written here. If a match occurs, then the index of item will be returned. So if let's say I found some value here at the middle position, so it will return the index of this middle position. So if I say what will be the index, index will be 2. So it will return the index 2 at this middle position, fine. Now if the middle item is greater than item, so in that case the item search will be in the right half of the list, and if the item to be searched is less, then the item search will be in the left half of the list. So let's see this by means of example, it will be more clear. So this is an array given, this is a list given. So in this list we can see that the index numbers are done from 0 to 8, so total size of this array is 9, and in the step 1 the item which we are searching for is 23. So what we will do, first we will calculate, this array is named as small a. So what we will do, we will calculate the middle value of this array. In order to calculate the middle value, we need to first get the beginning value as well as the ending value. So beginning location of this array, if I see, beginning is 0, that this is the beginning of this array. and ending if I see, so ending is this one, so ending location is 8. Fine. So now calculating the mid value, that will be beginning plus end divided by 2 in order to calculate the mid value. So in order to calculate mid value, first that will be beginning is 0, end is 8 divided by 2. So we will get value 4. So that means this fourth position is the mid of this array. So at this fourth position I will compare my value, that is that I need to search, that is this 23. So I will compare what is at value at fourth position, that is 13. So I will compare this 13 with 23. Fine. So now I will see whether 13 is equal to 23. No, it's not. So when 23 and 13 they are not equal, so that means I want to find that where this 23 will lie in this sorted list. Now obviously I know that 23 is greater as compared to this 13. So obviously the 23 should lie in this right half of the list only. So in order, so what I will do now, I have to update my array. I have to update the beginning as well as the ending positions of the array. So here now this is my new array on which I want to work. Fine. So on this array the beginning value is 5 now. So now updated value for beginning, this is 5. Okay, updated value of beginning is 5, fine, and updated value of end will be same, that is 8, because end is same, only beginning has been changed. Now in order to change beginning, what I have done actually, now in terms of algorithm, what I will do, I will write beginning equal to, this was what, 4 was in mid, so this is mid plus 1. Fine. So beginning will be updated by mid plus 1 and end remains same, that is 8, which was earlier also 8. Fine. So now in beginning I have value 5, in end I have value 8. So 5 plus 8, that is 13 divided by 2. So we will get 6. So this 6 is now mid of this element. So here at 6th position this mid I have calculated. So this 20 will be compared with the item to be searched, that is 23 now. Now this 20 and 23 they are again not equal. So if I can figure out this 20 is less as compared to 23, so that means 23 should again lie in the right half of this list here. So now again I have to update the beginning value, end value will remain same. So beginning will be, now this is my mid value, that is 6. So beginning is mid plus 1, that is 7. So here the beginning value is 7. So here we can see here 7 and end value remains same, that is 8. So beginning plus end divided by 2, again that is 15 by 2, we will get 7. So this 7th position I get the mid value now at the 7th position, and now I will compare it with the item, that is 23. This is also 23. So that means I have found the item. Now algorithm will stop over here and it will return this index 7, that I found the item at the index value number 7. Fine. So this will stop over here. So let's talk about the algorithm now. Okay. So now what we have done, initially we have initialized in the very first step, what I have initialized, that this is my beginning and this is my end. Fine. So initially we initialize this, that this is the beginning element and this is the end element. So this is the same thing we have done here. Beginning is equal to lower bound of an array, like this is my lower bound of an array, that is 0, and this is my upper bound of an array, that is 8. So beginning is set equal to the lower bound of an array and end is set equal to the upper bound of an array. Now after setting this, what we have to do, position, this position is actually returning the location which we have found at the end, that is the position of the element we are searching for, where it is actually lying in the list. So that will be returned in this variable named as position. Now what we'll do, we will start with the loop, because every time if I can see here, in every step I was calculating mid again and again, fine. So in order to calculate this mid again and again, we need to start with the loop. So here the loop has been started, we started with the loop, and the loop will compare till beginning value is less than equal to end value, till we don't reach to the end of the array, fine. So what it will do, it will compare the midmost value, it will find out the mid element, fine. After finding the mid element using the formula, then we will compare that whether this mid element, at this mid element we are getting this item. So now in this algorithm, instead of item, the variable named is name uses val. So this we can write it interchangeably, we can use val or we can use item in the algorithm, that depends that what variable we are sharing, fine. So here we will check whether it is present at that particular position. If it is present in position variable, we will return this value of mid. So value of mid is actually this index, we will return this value 4 if this value is matching, fine. If it is not matching, so in that case we will be checking whether that value is greater. If that value is greater, in that case you need to update the end value, means that we need to search in the left half of the array, fine. And if that value is, if this value to be searched is smaller, then you have to check for the in the left half of the array. If this value to be searched is greater, then we have to check in the right half of the array. So if we are checking in left half of the array, then obviously this is, if this is mid, so what we are doing is we are just changing. If we are checking in this array only, so obviously this end is changed. Now this is end and this is beginning, same. So beginning will remain same, end needs to be updated, and what it needs to be updated to, this position is what we call mid minus 1 and this position is what, mid plus 1, fine. So end will be updated equal to mid minus 1 if your element to be searched is smaller than the element which is present here, fine. And if your element to be searched is greater than the element which is present here, then you have to update the beginning to this mid plus 1 and end will remain same. Same thing is written here in the algorithm, fine. So if the element is smaller, then we have to update the end variable. If the element to be searched is greater, then we have to update the beginning variable. And otherwise, if we don't find the value and positional value is still equal to minus 1, so we can say that the element is not present in the array, and finally we can exit. Next technique is index sequential search. This is again to improve the efficiency for the searching in sorted file, but it involves an increase in amount of memory space, because here another index table will be created. So an extra auxiliary table called index table, this table is in addition to a sorted file. So this is extra overhead to the memory. So memory space complexity here will increase. So every element in the index table will be consisting of a key which is k index and a pointer which is a pointer to the record in that field corresponding to this key k index. Now in the algorithm, what we have to do is we are having two tables here. One is index table and another table is actually the table of the entries. So this index table is having two terms or two fields. First one is k index, which will be the array of all the all the keys present in it, and then we will be having p index, which will be pointer to a particular key here in our record. The advantage of this is the items in this table, they can be examined sequentially if all of the records they have to be accessed, and search time of this will also be reduced, as well as the deletion of this index sequential table, it will be most easily done by flagging the deleted entries. So these are the references which I have referred. Thank you.